what we did is we took one example. So for the writing purpose of algorithm, okay. So I think here. Okay, so this example we have taken. So for that purpose, we have written the algorithm also. So this is a very small example. For that purpose, we written algorithms also. Normally, in solution, what will be there? So always three things will be there. That is input, process, and output. So any kind of problem if you are taking, so three things will be there: input, process, and output. That is, input is nothing but what are things you required that you will gather it. Okay, then you will process in the sense whatever calculation you are doing it, those all things. Then output, whatever result you got it, that you are displaying or you are telling it. Okay, so there three things will be there. So depending on these three things, so in algorithm systematic way, just we return as a some steps. Okay, so that is these three steps are nothing but input, process, and output are here. Step number 3, 4, and 5. Okay, so here you are reading the input, that is x, y, z variable, three variables we have. So this problem was actually for identifying the average of three numbers. Okay, so here x, y, z, three numbers we are reading it. Okay, so then we are calculating the average. Okay, so in avg equal to what we did, x plus y plus z divided by 3 we did it. So you got the average, then just you are displaying it here. Okay, so these are the three steps normally we used to do it. So systematic way, what we are writing is we are saying as a this is the start and stop. So whatever variables we are using here, that we listed. Okay, so in between there is nothing but whenever you are writing the step by step procedure, so you have to analyze the problem. So that is nothing but we are saying as here started, then we analyzed the problem. That is nothing but we may require three or more than three variables here. Okay, so that is to calculate average of three numbers, minimum three variables are required, that is x, y, z. We took it. So result also you have to store somewhere. So that purpose we used one more variable as a avg. Okay, so avg variable fourth one. So those we are saying is these four variables we will be using in our solution. Whatever solution you are giving, in this solution we will be using it. So that we mentioned. Okay, so it's nothing but declare those four variables. Then actually this process we did, then stop. Okay, this is for a simple problem we did this one. Okay, so now just for the same kind of thing, so unless how we'll do it. Okay, if you have a pen and paper, better for write the algorithm for this one. Okay, that is write an algorithm to find the area of rectangle. Okay, so what all things we required here, can anyone say what all things we required here? Okay,
Step
length
1
and
start.
width. Okay.
Length and
Length
width.
and width were required. So how many variables were required? Three. Okay, which all?
So 3.
WL.
A
Okay,
is
what is
equals
A?
to WL.
Okay, correct.
Area.
Yes. So
Area.
here, what as I think I don't know name. Sorry. Okay. So I think Vedika was talking. Yes, sir. Okay, thank you. So Vedika was saying so that
Vedika.
is in this we required in this one three variables now. Okay, so that is to calculate the area. That is the result we are keeping. So result she was saying as a equal to W and L. Okay, so W into L. Okay, so A in that she is keeping the result. Okay, so you can give any name. So instead of A you can give as a result only maybe. Okay, so like that you can give any variable name. Then length and width. Okay, so those two things you require the input, then only you can calculate the actual your result, that is area you can calculate it. Okay, so that is what we written here, same thing. Okay, so here start. Okay, so declare, that is L and B I have written length and breadth. Okay, so that is then variables I have written. So here while analyzing we got as a two variables as of now. Okay, so we got two variables. Then here we are saying is a read value for L and B, then calculate area. So when you are trying to calculate it, if you saw we required here one more variable also. Okay, so that variable also I have to list it. So here I have to list that one, that is whatever I am using it, res. Okay, so here I have to list that one res, then display the result. So whatever result we'll get it, whatever after calculation, that is L into B if I did, so I'll get the result for rectangular. Okay, so that I can display it. Okay, so here print res value we are saying, then last step is stop. Any doubts? So my network connection
No,
is
sir.
weak. Sorry. Okay, so this one, whatever we are doing the recording, that also will share. Okay, so in Google, no, sorry, in YouTube only we'll upload this one. Okay, so it will be shared. Don't worry. Then say one more we will go for one more algorithm. Okay, so that is write an algorithm for find the area of triangle. Okay, so any other person? Okay, so other than Vedika. Okay, can you say how many variables are required? How
Three
many?
variables.
Three.
Three. Okay.
Three
Okay.
variables.
Which
Three.
one?
Three. Height,
A,
base, and area.
Width and area. Okay. So, sorry. This is actually instead of triangle, so make this one as the area of circle actually. Okay. So for area of circle, how many variables are required?
One.
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 One variable.
Radius, sir.
Radius. Okay. Only one is enough.
Yes, sir.
Yes, sir.
Yes. So where you will keep the result then?
So two variables, area and R.
Okay, that is the radius and result, whatever you are getting that result. Okay, that is the area. Okay, so that also you have to keep it again. That is the two variables. So there's nothing but always you have to consider whatever input you want to take, those many variables plus one output also. Okay, so minimum one output will be there. Depending on situation, you may have the more than one. So, but whatever example we will take it, maximum times we will take for one output only. Okay, so here for area of circle. Okay, so start. Okay, so again declare r we have did, so analyzing starting point we did as a again one only. Okay, that is r radius we are taking it variable, then read the value for r. Okay, then calculate the area. So while calculating we are saying is a pi r square. Okay, so 3.142 into r into r. Okay, so this result we are keeping. Okay, so for this purpose again we have to add it. So where you have to add here declaration will add one more thing, that is a res variable, whatever I'm using it, so that will add it. Okay, so that is a extra variable we are referring it. So here two variables we are referring it. Then uh, will calculate it, then display the result. So whatever result is there, that will display it. Last step is stop. Okay, so if you saw like this, whatever examples will take it, so maybe here calculation maybe in one step we'll do it or n number of steps we'll do it. Okay, so for that purpose maybe here whatever I have written as a calculate area, this is a one formula was there. Okay, so suppose you are considering as some mathematical steps will be there. Okay, so you will calculate some average calculus, you will do it. Okay, some integration things you will do it. After that maybe you are getting the result. Okay, so you have to write all those steps here. Okay, so what we'll do is while writing here, normally English letters we'll use. The English statement we'll write it. Okay, so suppose someone is doing the mistake while writing the statement. Okay, so that will be misinterpreted. Okay, there is nothing but whatever meaning was there, his intention may be different and whatever he written will be different only. Okay, or he written properly but whoever is reading that he will misinterpret. Okay, that is always it will make the confusion. So instead of doing like this, writing in terms of letters, we'll prefer the algorithm kind of, sorry, we'll prefer the some diagram actually. Okay, so if you saw the diagram notations, if you saw it, so we'll think as a okay, so this one you are doing it, this is that you're reading only, you're displaying only, you're calculating only, so those things. So for that we'll say as a flow chart. Okay, so next thing is a flow chart, that is a diagrammatic representation. Getting? Okay, so previous one, that is nothing but we had as a step by step we're writing in terms of English letters. Okay, so maybe some problem will happen, and it's if you're written like this for a big problem, it will like writing page to get theory only. Okay, so instead of doing that one, so what we'll do is just we'll represent using some diagrams. Okay, so that diagrams we'll call it as a flow charts. Okay, so here what we'll do is some representations we'll use it. So when if you are written one box means that you are reading or not. Okay, so what you are doing like that. Okay, so same problem we'll take. So average of finding the three numbers. Okay, so this is the flowchart we have written. Okay, so hope you understand my handwriting here. Okay, so that is start. Okay, so this is curve is here. Okay, it's not a straight line. Okay, these two are the curves here. These two are the actual straight lines. Okay, so normally we'll say this one is a oval. Okay, then this is a rectangular. Okay, so the straight lines are there. These two also. Okay, this is a rectangular. Then here this is a parallelogram. Okay, so this is a parallelogram. So again this is a rectangular. Okay, and again here this is a parallelogram, and here again this is the oval. So whatever start and stop is there, for that we'll use the oval. Okay, so and here some rectangulars we will use, or some parallelograms we will use, or some different rotations we will use it. Okay, so this is how we'll write it. So if you saw here inside that, again we are writing it. Okay, so normally by seeing this one only we have to understand what we are doing it. So in that which all variables are used, that we have to note it. That's it here. Okay, so here what we have written is a declare variable n1 n2 n3. Okay, so the previous example whatever we took, that is x y z, same thing. So here we are considering as a n1 variable, n2 variable, n3 variable, and average. Okay, so then reading n1 value, n2 value, n3 value, those three values we are reading it, then calculating the average. Average equal to n1 plus n2 plus n3 divided by 3, then display the average. Okay, so for what purpose, which diagram we have to use it, that is our next thing. Okay, so that is, so I have to use rectangular or parallelogram or oval when I have to use it. So those things only we have to study it. Okay, any doubts till now? No?
Sir, commas and full stop should not be used in algorithm or flowchart.
See, normally in algorithm you can use it, no problem. Commas, full stop. Okay. So here also in flowchart normally we will not use it. Okay. So here also n1, n2, n3 will use it. But what is the problem is with respect to some program, here you may get the problem that is the kind of is n1 space n2 if I given, or some people will think as a directly written as a n1, n2. Okay. So both together will be the one variable name that time. Okay, so that's why we are giving the commas. Nothing but this is different variable name, this is second variable name, like that. Okay, so maximum. Okay, so algorithm while writing you can use comma, semicolon, full point, no problem. Okay, flowchart you have to avoid it. Okay, but whenever more number of variables are there, you use it, no problem.
Okay, sir. Thank you.
Okay. Okay, so here next we'll go for the notation. Okay, so here the first notation is nothing but arrow mark. Okay, so here arrow mark, what is this? Arrow mark is nothing but flow line, will say it. Okay, so what is this flow line? It shows the program order of operation. Okay, so order of operation in the sense, this is the first step, then only we are going here. Okay, so after second step we are going here. So you can divert from here to somewhere to the last step also. Okay, so maybe in some program or some flow chart we'll see that one also. See, this is simple one. So what we are doing is step by step we return. So after one step we are going for a next step immediately. Okay, so that is a from which step to which step you are going. That is what we are representing it. Okay, that is the arrow mark you are representing it. So here this next immediately is there. So we are not seeing that much difference. So sometimes it may happen as a suppose after reading the n1, n2, n3. Okay, so you may go directly for some other step here. Okay, some other thing you will do it here, then you will come back here. Okay, so depends on the program whatever you are doing it. Okay, that is a flow line. Okay, then a second one is oval, or we'll say as a terminal. So this is nothing but start and stop whenever you are doing it. That is a start and stop whenever you are doing it. So that time you have to use it. So you are saying as a, this is a start of the algorithm, or start of the start of the flowchart, or end of the flowchart. Okay, so you can use here stop word also, or you can use end word also. Okay, so it's left to you. You can use that is start or end, or start or stop also you can use it, but it should be meaningful only. So normally we prefer as a start and stop only. Okay, then we'll use parallelogram. Okay, so that's input slash output. Okay, so input or output we are saying it. So what we are doing here is nothing but whenever you are reading something from the user or whenever you are giving something to the user, so always we'll use the parallelogram. Okay, so here whatever this is there, this is a parallelogram. Here what we are saying is whenever you are reading it or you are displaying it, so that from the user, if you are connected to the user, that time we will use this one. So who is user?
We.
Okay, so this is what we are doing is this one is nothing but we are saying the solution. Okay, so consider as a I am giving the solution. This solution I am giving to you only. Okay, so if you want to use this one, okay, this is the solution. If you want to use it, so you are the user. Okay, so whoever is using this solution, that person is the user. Okay, sometimes what will happen, I will write the solution and I will only use this one. Okay, so that time I am the programmer also because I am giving the solution. Okay, I am only the user also. Okay, so normally whatever you people will do, so you are the both now actually. Okay, that is you are only giving the solution. Okay, and you are only using it because you are not expert in these fields still, so you will only test yourself. Then after 4 years when you will become the actual engineers, you will work for some other companies and you will give the solution for the other people. Yes. Okay, so here what we are doing is just we are small programs or small things, we are solving it and we are only testing it also. Okay, so is it correct or not, like that? Okay, so here with respect to this one is user is we are only now. Okay, so read and display whatever we are doing it, that time we use the parallelogram. Okay, then rectangular. Okay, so rectangular whenever we are doing some processing kind of thing. So processing in the sense whenever you are calculating something or whenever you are referring the some memory address. Okay, that is a storage, normally we'll say it memory address. How many of you know what is memory actually properly in system? Okay, so not normal human life, there is also memory in our brain we normally will say. So keeping something. Okay, so normally we'll say as a memory. So in your system also you have as a something as a memory. Okay, that is normally if you know as a 16 GB, normally we'll say your mobile is supporting 16 GB or 32 GB, or your system has laptop has 1 TB of memory or 512 of GB, like that it will be there. Then you will be saying as a C drive, D drive. Okay, so whatever you will copy paste your movies or some documents, you will copy paste it. Okay, so that is you are keeping in some memory. So sometimes in program it may happen as a you have to refer those addresses, so where you kept. Okay, so that purpose, or if any calculation you are doing it, so those all calculations on the variables whatever you are doing, so for all those purpose we'll use the rectangular. Okay, so I think what all things we have in this one, these all things we have covered. Okay, so we stop here. So after that, whatever notations are there, that also a little bit will study. Okay, so in detail we'll go. That is what is if condition, loops. Okay, so whatever we have, so that time we'll study it little bit one or more notations. Then we'll use it. Okay, so next class, if possible, I will bring. Something as a when you have to use conditions. Okay, there is if condition or loops. Okay, then we will use those notations also. As of now, any doubts, anything?
No, sir.
No.